I'll just start the recording. I'll share the screen. This will be an important class. Pay very careful attention. I will do it slightly differently. Okay. So first we will discuss algebraic functions. Now the types of functions that we'll discuss are these. Um, we'll discuss some of the algebraic functions. Types of functions and their graphs. So algebraic functions, then we'll discuss logarithmic, exponential first, and then logarithmic. Exponential and logarithmic functions. Then we'll discuss trigonometric functions. After that, trigonometric and inverse trigonometric functions. So we enter into trigonometry in a smooth transition. Okay. So these other kinds of functions other than algebraic functions are also called as, these are also called as transcendental functions. Okay, this terminology you will not so commonly find in your textbooks, but this is an important demarcation. Now, algebraic functions are those functions which specifically satisfy a polynomial equation, like a polynomial equation. Algebraic functions are those which satisfy the polynomial equation. That means that the polynomial equation is like this. You'll have P naught, or I will do it okay, P naught plus P1 into f of x power 1 plus P2 into f of x whole square plus P3 into f of x whole cube plus Pn into f of x whole power n. Now for different combinations of for different values of p's, it will satisfy this particular equation. P can take any arbitrary values, P1 to Pn. Okay, so polynomial algebraic functions are those which satisfy the polynomial equation. So anything which is of the form log, exponential, trigonometric, they will not be able to satisfy this equation. Only those which are in the form of expressions, that they can satisfy this equation. So any function which does not satisfy the polynomial equation is called as a transcendental function. So it can be combinations of many functions, but it is basically trigonometric, logarithmic, inverse trigonometric. They all fall under this category. So now we go with algebraic. Just a second. So now we'll take some of the basic algebraic functions. All right. Now I'll show the graphs also. Function f of x is equal to x is the basic um, algebraic function, the simplest of algebraic function. And we know what the graph of f of x equal to x is. This is, you replace f of x is equal to, replace f of x by y, and then you will get the graph. What is it? It's a straight line. Graph of y equal to x is a straight line. Now let us do this exercise for each of this function. It will clear our concepts very solidly. What is the domain of this function? What is the range of the function? Is the function even or odd? Then is the function periodic? And what is the nature of the function? In the sense, nature of the mapping, 1 1 onto into. Okay, for each of the function, if we do so, whether it is invertible, if so, what is the inverse? For each of these functions, we will be doing this. Okay, better as I copy this part. Yeah. We'll be doing for each of these functions. So now let us come back here. So what is the domain of this function? Now I want all of you to unmute yourself and participate in this class, because actively participate. This class is full of participation. What is the domain of this function?
Minus infinity to infinity.
Very good.
So
This is
y
domain of this.
period.
Domain is R. That means x takes all real values. There is no value of x for which y will not be real. For all values of x, function is defined. All right. So set of all real numbers, or we can write this as minus infinity to infinity. Next, what is the range of this function?
R, sir.
R. Very good. The range of this function, you can see the graph extends from minus infinity to infinity. There's no binding. So range is R. All real numbers. Is it even or an odd function? Is it even or odd?
So actually, I'm not sure. I don't think we can tell because we check the even and odd from this line only.
Even odd, we check based on whether the graph is symmetric in the opposite quadrants or it's symmetric about y-axis.
Yes, sir. It's symmetric in the opposite
Opposite
quadrant.
quadrants. So it is odd.
Yes,
F of minus x is f of x is x. So f of minus x is minus x, which is minus of f of x. So it is odd function. It is an odd function. Periodicity. Is it periodic?
Yes.
Does the graph repeat itself? No. Okay, the graph doesn't repeat itself, so not periodic. Okay. Nature of the mapping: 1 1 into 1 1 onto bijective, many 1 into. Which type of mapping is it?
Bijective.
Very good. First, it is both 1 1 and onto. Okay. Why 1 1? Because you can draw any line parallel to the x-axis. Any line parallel to the x-axis, it will cut the graph only at one point. So it is 1 1. Okay, so it is injective or 1 1. And is it onto? For onto, what is the uh, what is the condition for onto? The range must be equal to the codomain. So range itself is R and codomain is R. So range is equal to codomain. So this is onto 1 1 and onto. So it is bijective. So it is bijective. So because it is bijective, it is invertible. Yes. Okay. What will be its inverse? Hmm. This is one graph, okay, whose inverse is itself. F of x is x. Now write x in terms of y. So this y is equal to f of x equal to x. Now you write x in terms of y. So x is y, and then replace x by f inverse of x and y by x. Replace x by f inverse of x and replace y by x. After you write x in terms of y, that will give you the, generally y is in terms of x, right? So we should write x in terms of y. So this is what you get as the inverse. Okay, this is the inverse of this function. So f inverse x is x. So this is one graph whose inverse is same as the original function. Okay, there's a basic of algebraic functions. Next, let us do the second one. F of x is equal to x square. That is, you write y equal to x square. All right. This is a parabolic graph. This is a parabolic graph. Y equal to x square. The nature, see, I'll write the nature of the curve also so that it will be easy for you. This is a straight line. This is a parabola. Now let us go into this. What is the domain of this?
R.
R. Good. For all real numbers, it is defined. All right. What is range?
R plus.
R plus including 0.
0.
So we write closed 0, open interval infinity. All right. Next is whether this function is even or odd.
Even.
Even function. It is an even function. F of minus x will be minus x of whole square, which is x square, which is f of x. So it's an even function. Is it periodic? No. Nature of mapping? Nature of mapping. Is it 1 1, onto, into, so on. If I say, if I say F maps R to R, then tell me the nature of mapping. Draw a line, draw a horizontal line. It cuts at 2 points, right? That means there are two values of x, which give the same function value. So it is many one function. It is many to one or many one function. It is,
So shouldn't it be 2 to 1 functions? Because technically there are only two. Like, why do we call it many to one?
we call it, see, either it is one to one or it is many to one. Here, of
But
course,
sir,
it
this
is
is
only
two to
2 to
one.
1,
Yes,
yes,
sir.
but there is no term. We have to distinguish only between 1 to 1 and more than that. There may be 2 will
So, but
map to
are
3.
like 2 to 1 functions are always quadratic functions, no?
Yes,
So
3 to 1 may
they,
be cubic.
yes, so exactly that's how we, but that we can have it.
You can have it, but there is from, we are talking from the perspective of inverting a function. From inverting a function, many one function cannot be inverted. They'll
Oh,
not be
okay.
invertible. Okay, this is many one. How about uh, onto or into? Onto or into? What is the definition of onto? The range should be equal to the codomain. Tell me now, what is this function?
So on to.
No, the range is the codomain is R. The range is only 0 to infinity. You see the graph,
Yes,
the
sir.
the negative values of real numbers, it is not taking at all. It only takes the positive values. Okay, so it is into. Okay, so by itself, this is not uh, uh, invertible function. It is no. However, by restricting, if we define, suppose I define like this, if we define f as mapping from 0 to infinity, that is, this is the domain, only the positive side. That means the graph only to the right of the x-axis to 0 to infinity. This is my domain, this is my codomain. If we define f such that f of x is equal to x square. All right. Now, if we define like this, then this function becomes 1, 1 and onto. Okay. For this inverse exists, then f is bijective in this case. F is bijective only in this case. If we restrict, this is called as restricted definition. We restrict the domain and the codomain. Then in that case, you get, f of x y is equal to f of x is equal to x square. Now I have to write x in terms of y. So x can either be plus or minus root y, but we omit because look at this. X can take only positive real values. So since but x belongs to 0 to infinity, therefore x is root y. So we get, replace x by f inverse of x and root y by y by x. So you get this as your inverse. F inverse of x will be root of x, provided you define function only for this portion. Okay. And let's see the graph in grapher. Something very important to tell you here. Y equal to x square. Y equal to x is this line, okay. Y equal to x square. Yeah, that's a black line. All right. Next, and y equal to square root x. This is the graph. Now you observe this. So we'll consider only the this portion in the um, positive x-axis. So this red curve is y equal to x square. Okay, y equal to x is this straight line, and y equal to root x is this green colored line. We will see that this y function and its inverse are symmetric about the line y equal to x. Okay, this always happens. Function and its inverse are symmetric about this line y equal to x. So the inverse of x square, if it is defined in a restricted domain, is root x. All right. So f inverse of x is equal to root x. That is the definition of inverse.
Excuse me, sir.
Yes.
Sir, how cubic polynomial can be 3 to 1 function?
How cubic polynomial is what?
3 to 1 function.
It can be. I'll show you. I'll show you.
Okay.
By the nature of polynomial means that only. They are graphs. I'll show you the graphs. First, let us do a simple cubic function, a simple cubic polynomial. Third, f of x is equal to x cube. All right. So we just plot y equal to x cube. Say y equal to x cube. So this is a curve. This is an interesting curve. You have to learn to plot it properly. Although this is cubic, interestingly, this is 1-1 function. Okay, the way you see, many usually cubic functions are not 1-1 functions. Anyway, now let us come to this. What is the domain? Domain. Domain of this function.
R,
R. It is defined for all real numbers. Range.
R, R,
R. Good. Because entire throughout there is no value of x for which f of x is not defined. So domain is R. And there is no value which f of x does not take. F of x takes all values from minus infinity to infinity. So range is R. Now is it even or an odd function?
odd,
Odd function. All functions with odd powers. Periodicity. It is not periodic. Nature of the mapping.
bijective,
Bijective. Very good. It is 1 1. And on 2 we discussed this examples, and so it is a bijective mapping. So you don't have to put restrictions on the domain and range. It is invertible because it is bijective. And what will be the inverse? What will be the inverse? I'll just push this down. Just give me a minute. What will be the inverse? So y equal to f of x is equal to x cube. So x will be equal to cube root of y. Therefore, replace x by f inverse function. X is equal to f inverse x, right? So, and y, replace y by x. So f inverse of x is cube root of x. So that's the inverse function. All right. Now, next I will talk about, this is something, quadratic expression. F of x is equal to ax square. F of x is equal to ax plus b is a straight line. Y equal to mx plus c, that kind of a straight line. All right, it's an you don't have to worry on that. This one, ax square plus bx plus c. In your schools, has quadratic equations done? Quadratic equations.
Yes, sir.
Okay. So now you see this, ax square plus bx plus c. Now this is actually, we'll go into great detail in quadratic expressions. I just want to put a quadratic expression, ax square plus bx plus c, represents a parabola. Okay. Now a, b and c, if I vary a, b and c, I get different results. Let us vary c. What does c do? You just see here. Right now this is giving a as 1, b as 1, c as 1. I am just changing c. Just see here. As c becomes greater, the graph moves up. As c goes negative, the graph goes down. So what is c doing? It is just increasing the function value. Got it? All right. So I'll pause. So let us pause at c equal to 1. When we do roots of quadratic equations, that time we'll see more things. But now, right now, c equal to 1 is this. What if I change b? I am changing b. C is fixed. C is 1 and I am changing b. So the position where, see, roots of quadratic equations you have studied, right? There are two roots, two real roots or no roots. Two roots means when the graph cuts the x-axis, the points where it cuts, they are the roots of the equation. That means if you substitute those points in the equation, you will get 0, the quadratic as 0. So now you see, these are two distinct roots. Yeah. Here, when it touches the x-axis, it has one repeated root. That means two real and equal roots. And then whenever it has gone up, it is not cutting the x-axis, it has no roots. And then both the roots are now in the positive, both are positive roots. So this is how it happens. B equal to 1. Let us see what happens if I change A. Very important. As I'm changing A, the width of the parabola is reducing. You see here. Okay. Now the parabola reversed its sign. Why? Because A is negative. When A is positive, this is ax square, right? So this term will dominate the sign of the function. This particular term will dominate the sign of the function. So as long as A is positive, you get the polynomial as positive. The ax square plus bx plus c as positive. When A is negative, you get the graph like this. Okay. So ax square plus bx plus c, it is parabolic. Domain and range, uh, the range depends on the calculation. I will, how do you find the range of this expression? Okay, it is not fixed for any function. You have to see its minimum value and maximum value. Okay, minimum and maximum values you have to see. So this is a quadratic expression. So range also is not a unique thing. Even odd, it is definitely not odd. It may not be even also, because it may not be symmetric about y equal to x. It is not periodic. It is not bijective. It is not directly invertible. Okay, just because we are talking about algebraic functions, I've talked about this. Now let me talk about, I'll delete this. Now the question of you asked about cubic functions, right? Y equal to x cube we have done. Now let us look at this function. F of x is, say, x minus 1 into x minus 2. It becomes a quadratic. It is a quadratic with roots at 1 and 2. Okay, roots at 1 and 2. X minus 3. You see here? Let's expand now. Now if you draw a horizontal line, it cuts the graph at 3 points. So 3 values of x are mapping to a single value of y. Let us say y equal to 0.25 is the line. See, it is cutting at 3 points. y equal to this, or horizontal line is cutting the graph at 3 points. At some places it will cut at single point. Okay, if I make it as 1.25, it cuts at 1 point, but it is 0.25, it will cut at 3 points. So it is many to one mapping. Clear? Now how it comes 3 to 1, and if I increase now, if I make this x minus 4, you see how the graph becomes. It is being cut at 4 points. This is a biquadratic expression or polynomial of degree 4. All right. So of course we worry about only the basic graphs. So I'll omit this because quadratic expressions, again equations, signs, we will, but just to give you an idea, I gave this right now. Now let us do this function. F of x is 1 by x. Now from basic algebraic we have gone to rational functions now. F of x equal to 1 by x. How will this graph be? This is a graph which is extremely important, very, very important. Okay, I'll choose a bigger this thing also. Both ways, in grapher and yeah, OneNote I'm showing this. So how does this graph? It's a reciprocal. Greater the value of x, lesser will be the function value. So as x keeps increasing, I'll show in this graph. As x keeps increasing, the value of 1 by x keeps decreasing, but it will never go negative as x is positive. 1 by x will not go negative, but it will keep going closer to 0. Okay, but it will never become 0. It will never become 0. And then when x becomes smaller and smaller and smaller, close to 0, x is say 0.001. So 1 by x will be 1 by 0.001, that will be 1000. So it will go up. So when x is equal to 1, function value will be 1, but when x is greater than 1, function value becomes lesser than 1, and when x is lying between 0 and 1, function value becomes greater than 1 and reaches infinity. On the negative side, the same thing holds. When x becomes negative, the y values are negative, but when x takes large um, values numerically but of opposite sign, that means, you know, see here -4, -6, -8, so on, then the graph will approach 0. Okay, and when x takes values closer to 0 but negative, then the graph approaches -infinity. All right, so now you tell me the domain, range, other things for this graph.
Domain is R minus 0.
Very good. Domain is all real numbers minus 0. 0 is the only number for which this is not defined. How about range?
So I think same
R
R
minus
minus
0.
0.
Very good. It is r minus 0. Because function never takes the value 0. It takes all other values. Is it even or odd function?
Odd.
Very good. It's an odd function. Periodic? No.
Only so like it's only one period, so you can't call it periodic.
Mm.
One to
So
one.
function is r minus 0 to r minus 0. This is the definition of the function. So nature of the
One to
mapping,
one to one.
1 to 1, very good. And it is onto.
Invertible.
So it is bijective. It is a bijective function. So invertible, yes. What is its inverse?
So for y is less than 0, x is positive, and for y more than
Hmm,
0, x is negative.
no, we don't. How do we do inverse? Y is
So,
in terms of x.
yes, sir.
We
So,
we write x in terms of y and replace x by f inverse of x and replace y by x. So you get, interestingly, f inverse of x is again 1 by x. All right. And we know that graph and its inverse should be symmetric about the line y equal to x. When you see this, the line y equal to x, the graph is symmetric about y equal to x. So when you invert the graph, you have to take a mirror image. You will get the same graph. You have to take mirror image about y equal to x line. You get exactly the same graph. Okay. So this is the nature. This is the reciprocal function. This function in calculus will play a very important role. Right now, you'll not know it, but in calculus, it will play extremely important role. This one. Next, fifth one. F of x is equal to, now we are coming to irrational functions. F of x equal to root of x. All right. Y equal to square root x. Let us see. So see the graph. Y equal to root x. This will be the graph. Okay. When we come into calculus, I will deal with it more carefully. But these are basic graphs that you should remember. That's why I'm going through. What is the domain? What is the range? Even or odd? Periodicity? Please tell. Domain? What happened?
0,
uh,
infinity.
0,
R infinity 0.
infinity, and all the range also 0,
Range? Yes. Closed interval 0 to open interval infinity. This will be the domain. It is defined for x greater than or equal to 0. For x less than 0, square root will of a negative number will not be defined. And range, you can see it will keep increasing.
0, comma
So, but isn't, I think it's forming a, no, sure.
Like what? It
So
will approach infinity much slower. Let's
yes,
say
sir.
you take x as 100, then f of x will be 10. If you
Yes.
take x as 10,000, f of x will be 100.
100.
So it will go slowly, but infinity is a undefined large number.
Yes.
So it will also approach infinity range. There is no, you cannot say there is some value of f of x which doesn't belong to positive real numbers. You will not find one. Now tell me whether it is even or odd.
Odd, sir.
No, it is neither even nor
So
odd.
it stops
So
at
for
zero.
negative
That's
value,
why.
we cannot define this.
Yes, yes, because f of minus x you cannot define because it will be under root of a negative. So this function is neither even nor odd. This function is neither even nor odd. And it is not periodic because it is not repeating. Nature of the mapping, given that f maps 0 to infinity to 0 to infinity. This is your set A, this is your set B. If this is your domain, this is the codomain. Then tell me, what is the nature of mapping? You can draw
Bijective.
bijective, you can draw horizontal lines. It will cut only at one point, it is 1, 1. Range is equal to codomain, it is onto. So function is bijective. So yes, function is invertible. What is the inverse? Y equal to f of x is equal to root x. So how is the inverse defined? X root x is equal to y, which means x is equal to y square, which implies replace x by f inverse of x and y by x. So f inverse is x square. And we did, right? X square inverse is root x. So root x inverse is x square. But of course, the codomain and domain will be this. You cannot expand the codomain now. Next, y equal to cube root of x. Now cube root of x will take all values. Uh, y will take all real values. This is the graph of cube root of x. All right, now you tell me the domain, range, even, odd, everything. What is the domain?
R, sir.
R.
Range is
Very
also
good.
R, sir.
Range is also R. Then you have even or odd. Tell me whether it is even or odd. Yes, it is odd function. F of minus x is cube root of minus x. Cube root of minus 1 is 1, minus 1. So that comes out cube root of x. This is minus of f of x. So f of minus x is minus of f of x. It is an odd function. It is not periodic. And then nature of mapping. What is the nature of mapping? F mapping R to R. Tell me.
Bijective.
Bijective, very good. It is 1 1. It is onto. This is bijective. All right. Then, so invertible, yes, because it is bijective. What is the inverse? What's the inverse? Y equal to cube root of x. So this is f of x. So this implies um, y cube is equal to x. So x equal to y cube. This implies f inverse of x. F inverse of x is x cube. All right. So these are some basic. Tomorrow we will do some very important curves in algebraic. In algebraic, tomorrow we will do mod x. We will do step x with its properties. That is, greatest integer function. Then we'll do signum function, sign of a number, and so on. Then we'll have a fractional part function. So these are some major functions we'll do. Then we go to exponential and logarithmic. So, all right. All right, shall we stop? Any questions? I will share this. After I finish the other algebraic part, I'll share this sheet in one sheet. Okay. So that will be easy for you. You will have a good reference for this. Any questions?